you, and I would like to thank the organizers of this wonderful conference for giving me a chance to be here. And yes, I would like to present work that covers similar questions as to those that Catalina has talked about, and it is a detail of one of the case studies that she has studied in the meta-analysis. And this work is called Forest Cover and Timberline Changes in the Carpathian Mountains during the 20th century, and this is a collaborative work done with Peter Weisberg from the USA. First of all, about climate change. We are living in a world that is becoming warmer, and this has implications for vegetation zones in the mountains, and the most obvious of these being rising vegetation zones and elevation and rising timberlines. This has happened in previous historical epochs, and it is happening now. So it was curious for me to see if this is happening in the Carpathian Mountains. And you can see that there are many forecasts of forests moving into even higher elevations. So how can we study increases in tree elevation? First of all, we can use maps, we can use photographs, we can use historical reports, we can use analysis of tree rings, tree density, and tree size. The rise of the upper timberline is an environmental process observed in all European mountains, and there are many reasons for the rise of the timberline. First of all, socioeconomic reasons, meaning a decline in mountain farming, and as a result, of course, succession into abandoned pastures. But at the same time, climate change is also influenced, and it is not really clear how these factors interact with each other, because, well, on one hand, socioeconomic effect can be seen very quickly, but on the other hand, climate is also an influence because it is auspicious for all trees and mountains to have a warmer climate. And we can see here in this book by Meyer that cultural timberlines that were formed by removal of forest above the on mountain pastures, they experience a harsh microclimate that climate warming could be auspicious to. And we also know that the response of a cultural timberline will not be the same as a natural timberline, climatic timberline. And it was also interesting to understand how this will happen. And in understanding the legacy, historical legacy of the calamitous change in the mountains, we can make a forecast of what will happen in the future. So other reasons to study forest cover in the mountains. That's because increasing mountain forests provide protection for seasonal floods, capturing rainwater. Also protection against avalanches and mud flows, which is also relevant to coastal regions, and of course additional carbon sequestration, which is important now for us during climate change. But also the controversial issue is that rising timberlines in Europe also means biodiversity loss in decreasing alpine areas and deterioration of cultural landscapes, so they're not as touristically attractive. So a bit of history that Catalina was also talking about. Of course, in the Austro-Hungarian Empire, capitalistic development led to intensive deforestation and agricultural expansion. So we could expect forest cover to be low in terms of Austro-Hungarian Empire. And the mountain areas, the forest areas were used as pastures. It was starting from the 1870s in the Austro-Hungarian Empire. After World War II, during socialization and collectivization, there were forests. Well, for one thing, forest was intensely logged, but forest restoration measures were also taken, and the latest pre-privatization measures after the demise of the Soviet Union also have an impact on forest cover. And research questions that I wanted to cover in this study is, well, first, has climate has it really become warmer in the Carpathian region in the last century? How has the forest cover changed on elevations over 1,000 meters? And do we observe a timberline rise in the Carpathians? similar to other European mountains. And the data that was used. First of all, maps of the third military survey, the 75,000 black and white maps that many of you know about. And this is how they look like. They covered my study region was split into West Carpathians, that covers Slovakian, Poland, Ukrainian Carpathians, covering Ukraine, North Romanian Carpathians, and South Romanian Carpathians. So the next data set was around 1930, and it involved WIG, Polish maps, that are 100K, and these cover Ukrainian Carpathians also. But also Slovak maps, revised maps of the third military survey, and they cover a part of Ukrainian Carpathians here. And for this plan village repertoire maps that were kindly distributed on geospatial org. And examples of these maps. For the period of 2000-2002, used Landsat imagery that was mosaicked together, altogether 13 scenes. And the study area are all elevations above 1,000 meters that could be distinguished from historical maps. The Landsat classification had a 78% overall accuracy. And my classes were broadleaf forest, coniferous forest, shrubs, grasslands, rocks, logging. And major issue was the accuracy of the classification for shrubs in mountains. I think many people are aware of this issue. It's very hard to distinguish the shrubs from lots of imagery. So I used imagery from Google Earth and online digitizing to discern between the shrubs and the forest, because it's very important for timberline, studies of the timberline. And after this improvement correction, the accuracy rose to 88%, and the forest non-forest accuracy 96%. So consider this to be fairly well to compare. Next, climate data that was used. Weather stations over the whole Carpathian region, 48 stations, and for 1961-1990, I computed the average July temperature by detrended ordinary cragging. And why was this done? I did this to find the geographical situation of the 10-degree July isotherm, which is considered to be a climatic isotherm, so it's a territory where it's too cold for trees to grow. So this is the natural limit of trees. So I wanted to compare this to the data for maps, for validation, and for other questions too. So these are the data sets, and as to the first question about climate change, because climate change resulted in periods of warming in the Carpathian region, and these are trends for July. And after following IPCC, this is June, July, August trends, summer trends from 1901 to 2000, 1910 to 1945, 1946, 1975, and 1976, 2000. And we can see that the statistically significant trends are circled in a black circle. You can see that there have been two periods of warming during 1910 and 1945, 1976, 2000, with the last period of warming being the most intensive. And why have we chosen the summer trends? Because these are really the most important temperatures for trees growing at a high elevation when they have a very short growing season. So the first answer to the question, yes, there has been warming in the Carpathian Mountains, and we can talk about tree lines responding to global warming. Next slide is forest cover change within core region of Carpathians. So remember the West Carpathians, Poland and Slovakia, with the green line, Ukrainian Carpathians with blue line, North Romanian with red line, and pink South Romanian Carpathians. And I have a graph here of forest cover. That means percent of territory that is covered by forests and elevations over 1,000 meters. And we can see here trends of West Carpathians forest growth and North Carpathians forest decline, and Ukrainian Carpathians and South Romanian Carpathians a little bit increased, but not very much. And here the time periods 1880, 1930, and 2000. But the next step was, for me, this is out of the total area of the region. The next step was to see, not out of the total area, but out of the total area that's suitable for tree growth, meaning below the climatic timberline. And here we see a more interesting picture that the start, 1880, Austro-Hungarian Empire, the forest cover ratio for all the four regions was comparably equal. It doesn't have a big difference between the regions, but at the end, to 2000, forest cover changes are very different for the regions. And I consider this to be a result of different socioeconomic conditions and different forestry policies for regions. And now on to forest cover profile. How has forest cover changed along elevation gradients? So here on the x-axis, we see elevation gradients, so 1,000 to 1,100 meters, and up to 2,100 meters. And regions West Carpathians, Ukrainian Carpathians, North Romanian Carpathians, and South. And it was a little bit cut off, but the green line is 1880. The blue line is 1940, and pink line is 2000. So, first thing that we can notice here is that the green line and blue line are very close together, meaning that forest cover has not really changed since 1880 to 1940. And the most changes have occurred in the period from 1930 to 2000, this pink line. And also, this is the climatic timberline, so this is the elevations at which the climatic timberline goes. Next thing that we can notice that there has been an increase in forest cover from 1930 to 2000. You can see this green sliver here, and it is apparent in all the four regions. And in West Carpathians, you can see it at all elevations. All elevations have forest cover increased. But in Ukrainian Carpathians, North and South Romanian Carpathians, we can see this forest cover increase only after a threshold, for instance, North Romanian Carpathians, 1,400 meters. And below that, there's been a forest cover decrease in these three regions. And also, we can see the amount of territory that can yet be afforested, theoretically, the area that is below the climatic timberline. And we can also note that the profile is forest cover as in 2000 is closer to the climatic timberline than it was in 1880. And the big question here is how trustworthy is the survey information from the maps? Here, when I digitized the forest cover from the 1880 maps, there was an interesting, very peculiar thing I observed. A lot of deforestation above the timberline in Carpathian Mountains in South Romania. And it was very peculiar because very big amounts of deforestation. So, of course, the question arose, is this trustworthy or not, and how this information should be treated? The orange is deforestation above the climatic timberline, and the climatic timberline is this blue line. This is the July interpolation. And on the satellite imagery, we see that this is cover that looks like trees, maybe at a shrub. After a comparison with Google Earth, we see these are actually shrubs. And so we see that these territories, the ones that were orange ones here, this actually it wasn't forest but shrubs, and it's very likely that the surveys here mistake those two forest covers. So my way out of this was just to mask the unlikely areas from analysis in order for them not to interfere with the general picture. And here we can see what difference this made. Before the masks were applied, we could see a large amount of deforestation and forest cover profiles. And after the masks were applied, you can see that deforestation is not here. And it's very likely that it was mistaken. Yes, and the masks covered 1.1% of the study area. So now, as to forest cover change along elevation, 1,000 meters to 2,000 meters here, and percent of territory that has undergone change over the elevational thresholds. And this red line meaning deforestation near timberline, orange line meaning deforestation at other elevations, and likely, here we go. This is, the green area is the afforestation, and red is the deforestation. And you can say this is afforestation at timberline, the one that is closest to the x-axis, and deforestation and afforestation in other territories. And here we can always also see the net change, the thick black line, which, by which we can estimate the amount of change that happened. And we can see that during 1880, 1930, not a lot of change happened. The only significant change, net change that happened was in the West Carpathians near the timberline. So we move on to the next period, 1930 to 2000. Here we see a picture that shows more change. Well, the first thing worth noting is afforestation near the timberline in all four regions. So this is a picture that is similar over all the Carpathians. There is afforestation near the timberline. And another thing worth noting is in the three regions, Ukrainian, North and South Armenian Carpathians, there is a lot of deforestation at lower elevations. While in the West Carpathians, we don't have this, we have a forest covering a piece of the full Carpathians, and of course, a piece near the timberline. So we could say that most changes happened over 1930 to 2000, and these changes were, first of all, decrease near timberline and decrease of forest at lower elevations in three regions. If we analyze the forest cover change by slope aspect, we can see that there is much more afforestation, the green font, much more afforestation at south and southwestern slopes, which may reflect afforestation of previously deforested pastures, which were usually made on south slopes and south sunny slopes. And we look at timberline changes. Well, how to read these graphs? First of all, four regions: West, Ukrainian, and North Armenian Carpathians. These were lines chosen for map and satellite information, the real line that circles a mountain. And buffers were made around the 1880 line, and I've seen how it changed in 2000. And first of all, a buffer zone, 74 meters above and below the 1880 timberline. This is connected to georeferencing errors. So we can see here that the red numbers are the coniferous timberline, and the green color means deciduous timberline. So we can see here that 34% in West Carpathians and of coniferous timberline went into the buffer zone, so it's not, you can't really say it's just a buffer zone. And 52%, much more of the deciduous timberline went into that buffer zone, and the numbers are fairly similar on all the Carpathians. And after that, we have 100, 200, and up to 1,000 meters of elevational thresholds of how the timberline changed. So here we see that the timberline has risen in 72% of the length of the coniferous timberline in West Carpathians, and in Ukrainian 74%, 78%, and 70%. So most of the coniferous timberline has risen. And when it comes to deciduous timberline, the numbers are a little bit less, 67%, 46%, 49%, and 57% has risen. And decline. About the decline of the timberline, you can can see that much more deciduous timberline has declined in elevation than coniferous timberline. So from these graphs we conclude that mostly the coniferous timberline has risen, and most of the deciduous timberline has gone into the buffer zone. So from here we conclude that over the last 100 years the coniferous forests have expanded in elevation. Well, and my conclusions are that temperature interpolation is another method to verify information about forest and maps and information that is connected to high mountain forests and the timberline. With a similar starting point, forest cover in the Austro-Hungarian Empire, the countries have found their different ways of development, which has resulted in different forest cover ratios for different regions. We have also seen that most changes happened during 1930 to 2000. We have observed timberline rise in all regions, and we have seen signs of forest increase at all elevations, only in West Carpathian Mountains in Poland and Slovakia, which brings to mind a forest transition happening in that country, and only in that region, so not in the Carpathian region. And I would like to note that this work has been supported by a CRVI award and Ministry of Education and Science of Ukraine, and thank the people at MAPI-WIG and Geospatial Org and UNESCO especially for sharing valuable map information to make this possible. And of course, Mitrich tools for digitizing Google Earth, CRU and KMMI for access to private data, and USGS for access to satellite imagery. And thank you for your attention.